Okay, in this tutorial we'll continue working with these right triangles, but now we're going to change the radial distance. And the reason being is that since currently we're using the sine and the cosine functions along with the unit circle, and it allows us to plot points along a circle and use these kind of right triangles. But if you were just to increase the size of the circle a little bit and change the angle, then maybe your point would start here, and then your next point around the circle, instead of being here, might be up here, and the next point maybe is over here being up here. So suddenly your point might go around like this, and you'd end up plotting a spiral, say like a polar spiral or something like that. And then you can start really doing a lot more cool, fun stuff. It gives you control, and all you have to know is about the sine and the cosine functions and the radial distances. So this typically, when you're using the sine and the cosine functions, what they're doing is they're returning a value essentially when you're using it in conjunction with the circle that's based on a radius of 1. But really there's a correlation. What we're doing is we're finding a correlation between, say, this point, this xy coordinate, and how it is correlated between an angle right here and a distance. All right, so they're correlated somehow to each other, and the formula that you would normally see when you're doing these kind of things, if you wanted to find, say, this y coordinate here and the x coordinate there, the coordinate would be, the equation would look more like this: y equals r times the sine of theta, like this, and then the value for x would be x is equal to r times the cosine of theta. And the reason that is the reason it's been working in our case at all times is because our r, which is our radius of the circle, or our radial distance, has always been 1. So we take the sine of pi over 4, which is 45 degrees, and it returns 0.707, and it multiplies it by 1, and it gives you 0.707. So now what we can do is we can now use this to increase the size of the circle. Here it's 2 meters in diameter, 2 meters, which means it has a radius of 1 meter, but I'll make it 4 meters in both directions. So now it has a radial distance of 2. And now here's my right triangle down here, but now I want to make my right triangle extend up to this point on the circle. And the way you do that is your equation then for the triangle in here, when you want to calculate, in this case we're using pi over 3 for the angle. So for the cosine, or the x value in this case, it's going to be not just the cosine of that angle, but you want to precede it by multiplying it times the radial distance. So it's going to be 2 times the cosine of pi divided by 3, like this, and then this is going to be 2 times the sine of pi divided by 3, like that. And there it is. Now our radius, our hypotenuse has a radius of 2, and let's go look into the numbers. We'll go inside, we'll look between this point and this point, and notice it's not showing it right. It shows it at 1, because remember, every time, just reinforcing this, apply the scale. Then I go into edit mode, and there it is, 2 meters for our radial distance, like this. And we'll look at it all. If I just press A, it'll get all of them like this here. And let's see if the angles are actually set now here, if it's smart enough to know the interior angle. Sometimes it only shows you the exterior angles, not the interior angles. So I'll turn the angles on and the faces off. So it says pi over 3 is our angle. And for this, so pi divided by 3, so I'll just get the calculator, right, and I'll bring up pi divided by 3 is the angle we entered, and that equals 1.047. Sure enough, there's your interior angle of 1.047. It shows this angle to be, I don't know if you can read it or not, it shows it as 1.57. That sounds like a 90-degree angle to me, because that's just pi divided by 2. And then this one up here, yikes, this one here is 0.0524 for this angle, and well, we can just see what that is. That would be pi divided, well, it's actually just going to be the resulting angle. So that's going to be 90 degrees, and that's going to be, these all three should add up. So I should have 1.047, right? 1.047 plus 1.571 radians equals 2.618, and then plus 0.524 plus 0.524, and look at that, 3.14. So the interior angles equal pi, or the same as 180 degrees, just what you would expect for the interior angles of this triangle like this here. Alright, well, hope that gives you some more ideas about how to work with these cool, powerful tools, and pretty soon we'll be able to do lots of cool, fun stuff. This actually preps you for some of my other lessons already, because a lot of it's just based on these basic concepts on some of the introductory tutorials that I'll have out there on my Sci-Fi Animator website. Okay, well, that's it for now, and I'll see you in the next lesson.